All right, let's do our derivative of ln of x squared plus 5x minus 3. So help me out there. What do I know about ln functions? What's the just the derivative of the ln of x again? It's 1 over x. The derivative of that's 1 over x. Well, in this case, I've got a little bit of complication because it's x squared plus 5x minus 3 inside the ln. And so how do I handle that? Well, it's chain rule, isn't it? Just the chain rule again. Our outside is the ln, the inside's the x squared thing there. So what about that? Derivative of the ln is 1 over, now in this case it's 1 over the inside stuff, isn't it? So it's 1 over x squared plus 5x minus 3. But I have to multiply that by the derivative of the inside stuff, 2x plus 5. And so all told here, our derivative is, we can just write that simply 2x plus 5, couldn't we? Over x squared plus 5x minus 3. With me on that? Okay. All right. Now a little, just ever so slightly more complicated one. Actually, different ways we could do this one. Let's say we've got y is the ln of 3x over x minus 3. Basically the same, isn't it? As the one before, except for this in here. A little more to that one. But, again, the derivative of the ln is just going to be 1 over whatever's inside here, if we just leave it like this anyway. And this is why I brought this one up. So it'd be 1 over the 3x over x minus 3. We'll talk about that in just a second. Then I would do the derivative of this, which, how am I going to do the derivative of that? Quotient rule. So that's going to be low d high minus high d low. So x minus 3 times 3 minus 3x times 1, to do that right? Over low squared. Now, simplifying this, well, what about that? 1 divided by, if I write it like this, what does that mean? 1 divided by 3x over x minus 3. Doesn't that mean flip this over? And so that's just going to be 3x, I mean x minus 3 over 3x, isn't it? Because that's the same as 1 times x minus 3 over 3x. Just a little bit of... So that's just x minus 3 over 3x, right? Simplifying this, well, we got 3x minus 9 minus 3x over x minus 3 squared. Well, that works out pretty good because the 3x's go away. And then what else can I do there? Can I cancel out? Yeah, cancel out the x minus 3 with one of the x minus 3's there. And then even that's going to give me this. And I can do even a little more because that can be reduced by 3. Whoop, 1 there, 3 there. So I get minus 3 over x minus 3. Okay? How about that? All right. Yeah, now let's go ahead and talk about, that's our ln. What about logarithms other than base e? Well, really, the key ingredient there is change it over to base e or ln. If I've got log base 2 of x, let's say, y equals log base 2 of x, can't I very easily there change that over to ln? What would that be in ln terms? Well, by the change of base theorem, it's ln of x over ln of 2. And that's really the key to doing bases other than e. Change that over to ln because we know ln, because that's really just a constant. 1 over ln of 2 is a constant times the ln of x. So the derivative is just going to be the derivative of ln of x, but times this 1 over ln of 2, isn't it? What's the ln of x? It's 1 over x, isn't it? So we wind up with 1, and this is the way normally they write it. So if you've got log base 2 of x, the derivative is 1 over x, but the x is times the ln of 2. Guess what it is if it's log base 3 of x? The derivative is 1 over x, but times the ln of 3. So that's really the only thing to it. If you have another base besides e, if you have something other than ln, you just have to multiply by whatever that base is. It's 1 over x times whatever that base is. One times the ln of whatever the other base is. Pretty simple. If you know that about that, okay? All right, now, similar thing happens when we have an exponential other than base e as well. We haven't talked about those, but something similar happens there. So we've got an exponential with a base other than e. Like 2 to the x. F of x equals 2 to the x. Well, the little trick there is to point out this. Probably maybe have seen this somewhere along the lines before. But take a look at this. If I do e to the ln of 2, what do I get there? Gives me 2. Yeah, because the e and the ln cancel out. Now usually we're canceling out to get 2. However, let's reverse this and say, hey, I can write 2 as e to the ln of 2. And you might be thinking, why in the world would I want to do that? Well, there's a reason. Okay. I can write 2 to the x. I can write that as e to the ln of 2 times x. In other words, substitute e to the ln of 2 for 2. Okay. Why would I do that? Well, here's why I would do that, because that is now something I can do derivative of, right? Because I know we talked about the derivative of e to a power. The derivative of e to a power is, well, it's just a little chain rule, isn't it? The outside is the e to the power. Well, e to the power stays e to the power. Then I multiply by the derivative of the power, don't I? What would be the derivative of this power? Well, the derivative of x is 1, so that leaves me ln of 2, isn't it? Okay, well, now let's reverse here. What is this right here? 2. Here it is. We started with 2 to the x. Our derivative turned into 2 to the x ln of 2. Isn't that similar to what we had with the log other than base e? Yeah. Turns out the derivative of 2 to the x is just 2 to the x, but you have to multiply it by the natural log of 2, the base. So if you have a base other than e, it's basically the same. You do the derivative is, itself, but you do have to multiply by this extra factor, ln of 2. So if I have any base other than, well, it works for base e too, so for any base a, the derivative is going to be that same exponential, a to the x, but times what? ln of a. So that's what happens when you have something other than e to the x. If you got 2 to the x, 3 to the x, 500 to the x, that's what happens. You multiply it by that extra factor of ln there. Okay? All right. Well, let's try those out for size here. Okay, so if we've got y equals 8 to the x squared minus 4. Well, if it was just 8 to the x, it would be 8 to the x. The derivative would be 8 to the x times the ln of 8. Well, the complication here is the chain rule, isn't it? I've got that. It's just now I've got to do the derivative of that times it by that too, don't I? So my derivative, do you see here, is, instead of x, I've got x squared minus 4, so it'd be 8x squared minus 4 times the ln of 8, wouldn't it? But then what else do I have to multiply it by? 2x. The derivative of the x squared minus 4. Exactly right. So if you have a base other than e, you just have to multiply it by this L. Now, if you think of it, if you think about it though, even if it was e, if I multiply by ln of e, what's ln of e? It's 1. So that, I guess you could technically say ln of e is there, it's just that ln of e is 1. So it's really the same for all these. But anyway. Is this okay? All right. This one has maybe both kinds. All right. What if I have 5 to the 4x times the log base 5 of 8x? What do you got there as far as derivative? Well, much is going on here. We've got, give me some rules involved here. We got product rule, probably one out of the box there, and chain rule. Yeah, definitely have product rule and chain rule along with these derivatives of logs and exponentials as well. Okay, so yeah, product rule. So by product rule, the way I do it first, 5 to the 4x times the derivative of the second. All right. So the derivative of log. Well, on the derivative of the log other than base, if it's just log base 5 of x, then the derivative is 1 over x times, and then you multiply that by the ln of the base. Well, with log base 5 of 8x, wouldn't it be 1 over 8x? This is, instead of x, I've got 8x. And then times the natural log of 5. And then I'd multiply it by what else? Multiply by 8, yeah, because that's the derivative of 8x. Okay? And so, lo and behold, it turns out the 8's just go ahead and cancel, don't they? Okay. Plus, then I have to turn around and do the second, or whatever order you want to do it in, times the derivative of the first. Well, that's the exponential. And on the exponential, you just do, 5 to the 4x, the derivative is 5 to the 4x, times the natural log of the base, 5, and then times the derivative of the power, which is 4. So let's see. Clean it up. Not much you can do. 5 to the 4, other than cancel those 8s. 5 to the 4x over x ln of 5. Over here, probably, I don't know, right, you got a mess. So probably write the 4 first. Then the rest, whatever order you want to write them in. 5 to the 4x, log base 5 to 8x, ln of 5. It's, yeah, there's just a bunch of terms there. Something to that effect. Question? Yeah, okay, yeah. She's saying, what if we use the change of base theorem there, then we could get the cancellation of the ln of 5s. Okay, I'm with you there. Sure, sure. There's usually more simplifying you could do if you spent a little more time or a lot more time. You could probably get it way on down there, but sometimes you don't see simplifying like that, and that's fine. But yeah, she's right there. I could do what, ln of 8x over ln of 5 for that, and then that will cancel the ln of 5s out there. So yeah, good point there. That does simplify it a hair more. So good suggestion. However, would I count it wrong if you just left it out? No. But maybe to get the answer that matches in the back, look for those little things.